We choose to go to the moon in this decade and do the other thing.
Discovery, go at throttle up.
Discovery, roger, go at throttle up.
Not because they are easy, but because they are hard.
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Houston, Tranquility Base here. The Eagle has landed.
Hello. Sorry, I'm having a few difficulties this morning. Thank you for bearing with me. Welcome to Orbit at a Tilt. You guys look great. I'm Adam Tilted. This is the show about space and science that is fun, informative, and easy to understand. Today we're going to be talking about the departure of the Cygnus spacecraft yesterday. I think it might have been Sunday, actually. So we're going to be watching that footage and taking a look at how that process goes. So that'll be fun. I will also be telling you about a lunar eclipse and a solar eclipse that are coming up soon. And we will look at some other sky watching things if we have some time. If not, then I'll catch you on that later in the week. So first, let's talk about the Cygnus. Actually, first I'm going to share this out, and if you don't mind, that would be great. I want this to get as many views as possible because I want everyone to understand and love science as much as I do. So, thank you. I also want to introduce you to the tip jar, which I forgot to put in the description, but I'll put it in there later. Actually, I'll talk about the tip jar another time when I have that stuff ready. All right, so the Cygnus spacecraft. Last week, I showed you the progress arrival. And when we looked at that, we saw the Cygnus spacecraft that was attached to the space station. Well, on Sunday morning, very early, it was released from the space station, and now we have NASA has made that footage available. So I wanted to show you how this goes. I thought it'd be fun. We saw a docking, so now we're going to see a release. All right, so let me switch over to the movie. Hold on, there we go. Here I am in the corner. Make myself a little. I'm fighting a migraine today, which is why I'm off and why I have the glasses, because the lights are like ice picks in my eyes. Okay, so we're going to be looking at this coverage. There is the Cygnus right here. It is attached to the Canadarm2. The Canadarm2 attached to it and unberthed it from the dock. I think it was the Harmony 1 dock, and holding it out about 15 meters away from the station, getting ready to release it. Now, Cygnus has been attached to the space station for 52 days. It was launched from Wallops Flight Facility in Virginia on May 21st. And I think we have footage of that launch. Hold on. Let me skip ahead. Yes, there we go. Go back. Okay, so here was the launch. it took about just under 3 days for the Cygnus to reach the station. And it was carrying 7,700 pounds of food, supplies, science experiments, and we can see here it's being captured here. Okay. All right, so this is a joint partnership between Northrop Grumman, who built the Cygnus, and the rocket that it launched on. Their flight control is in Dulles, Virginia. The flight control for the International Space Station is here in Houston. So they are collaborating, they are in partnership with this whole operation. Northrop Grumman, the ground control team from both used the arm. They didn't show the footage of this, but used the arm to undock the Cygnus from the station. And what will happen next is that the ground control in Houston will guide the astronauts that are in the cupola workstation. I'll show you where that is in a minute. They're guiding them and passing that control off to those astronauts. So up until now, it's been ground control. In a little while, they're going to hand it off to the astronauts, and they will be the one that actually initiate the release sequence, which is a whole series of commands. So we're going to watch this play out.
Here's what I found on the
Oops, sorry. Siri's getting a little excited. I wanted to point out something else, sorry. Oh, right here, this is the SpaceX Dragon capsule that we can see right there. Man, I'm sorry about the technical difficulties. Like, I need this today. Okay, come on. Come on. Come on. Seriously, what's the problem? Okay. All right, I'm back. All right, so we can see the SpaceX Dragon. That this is the Cygnus. It launched in May, brought 7,400 pounds of food, supplies, science experiments to the station. It's been there since May 24th or so. And now it's ready to come back, and they've packed it full of all the trash. So it has 6,600 pounds of trash inside, and it has 6 satellites that it's going to deploy after it separates from the station. Okay, so let's we'll move this ahead in time. And they're about to get the go for separation. And you'll see this is the ground control. I've got this sped up 2 times. Ground control in Houston, they're checking back and forth with the astronauts. They are about to cross over New Orleans in the Gulf of Mexico. The Cygnus also, the Cygnus also reached another milestone for the International Space Station. Oh wait, I want to go back and show you that because that's interesting. This is not something that might not be intuitive, but while the space station and the Cygnus are performing this operation, here's the space station. You can see it's right over New Orleans and the Gulf of Mexico, and it's going to be going down here, and it's going to be like dropping off the Cygnus, like right along this area you can see right there. Okay, so the Cygnus is then going to go on its own trajectory and do its own thing, and we'll talk about that. after we watch the release. Okay, let's go back. All right, so let's see, where's my next timestamp? All right, we're gonna speed up even more. Okay, we are getting close to the release, and I'm gonna show you the release in real time, and then I'm gonna show you the release sped up, because you'll be able to see in the sped up version, you'll be able to really see like the magnificence of what's happening here. But also in the real-time version, notice how slowly everything appears to go. But remember, right now the space station and the Cygnus are traveling about 5 miles per second. About 254 statute miles above the Earth. And by the way, a statute mile is just a fancy way for saying a mile. So. Okay, we're getting close to release. So let's see, I'm just gonna move this up a little bit. Okay, so this is watching from the Canadarm2. We're gonna see it release the tether. I mean, not the tether, what are the clamps. And I'm letting this roll at real time. Oh wait, let's speed it up a little bit. We've got a ways to go before anything happens. Okay, there we go. All right, now this is in real time. We're getting separation. You'll be able to see the spacecraft start to move away in the frame. By the way, I can't remember if I mentioned this, but this spacecraft did a test to see if it could be used to raise the elevation of the ISS. Okay, see it starting to go away. And it was able to accomplish that. It did a 50-second engine burn to raise the altitude about 295 feet. All right, we're right about over Brazil. I'm sorry, Southeast Colombia. You can see the arm backing away. The Cygnus is about 4.5 meters away from the arm when the arm stops, and it's about 15 meters from the station. And it's at what's called station keeping when it gets to that point. Station keeping means that it is in formation and not moving relative to the other parts of the fleet. So in other words, it's traveling at exactly the same speed as the space station, and it's staying the same distance away. All right, in just a minute, we're going to see the departure burn, and I want you to look around these areas. You might see a little flare. Should be coming up in about 20 seconds. Okay, you see those little, it's subtle because it doesn't need very much of a burn. but it is moving now away from the station at about a half a meter per second. It gradually will increase its acceleration relative to the station. All right, now from this point, the view is just going to be pretty much the Cygnus moving away from the station. So I'm going to go back and I want to show you this with it sped up a little bit, because then you can really appreciate kind of the maneuvers that are happening. So let's go back. All right, we're going to start here, and I'm going to speed this up 5 times. And I just want you to watch the whole thing again. Here it's still attached to the arm. It's been released. Again, this is 5 times normal speed. So there it goes. The arm is retracting. Getting ready for that burn. Watch the Cygnus. Keep your eye right here. There it goes. See that burn? And it's flying off. It's really beautiful. Don't forget, if you like this kind of stuff, share it, comment, invite your friends to like the page. That's a good question, Franco. It's actually not air resistance that propels an object. It is law of physics. If every action is met with an equal and opposite reaction, so if you force an explosion out of the back of a rocket, then the opposite reaction is to push whatever the rocket is attached to, the other way. So that in space, that's the same. So, and if you and I were actually floating in space, Franco, and just next to each other, and we pushed each other, we would both move away from each other. Depending on who pushed harder, one would go further than the other. That would be a fun contest. You want to do that? Ooh. An arm wrestling contest in space, that would be crazy, because then you'd be like turning around. So again, this is sorry, I'm getting off on a tangent. This is Space Center Houston. No, this is NASA Johnson Space Center. I really want to go here and show you guys this, but I do need some help with the funding for that. Because the travel, it doesn't cost that much to get in, but the travel cost for me is $120 just to get there and get home. Ouch, I know, right? So that's a little steep. So any help you could give, you can become a monthly sponsor at patreon.com/AdamTilted. Or you can use the tip jar at paypal.me/AdamTilted. Any little bit helps, and I'm just stowing it away until I have enough to do something fun. Okay, so let's also talk about lunar eclipse and solar eclipse, because we've got some of those coming up soon. And by the way, if you have any questions about what we just watched, then be sure to put those in the comments and I'll come back and answer them as soon as I can. All right, so a lunar eclipse is happening Next Friday, on the 27th. It will not be visible for North America. So I'm not going to get to see it. But it will be visible for Africa, Europe, Eastern Europe, even Australia, New Zealand will be able to see some of it. So a lot of the world is going to get to see this. And this little diagram will show you when you'll be able to look at this. So in the middle here, you'll see it all day. Over here in I'm not even pointing where you can see. Over here in Australia, you'll be seeing the eclipse when the sun comes up and the moon goes down. No. Sorry. When the moon yeah, I was right. Never mind. I'm talking myself out of the truth. Did you ever do that? Okay. Now, the interesting thing is, I gotta stop saying that now. Did you know that for every lunar eclipse, there is a corresponding solar eclipse? Remember that a lunar eclipse is when the moon passes between the sun. It passes through the Earth's shadow that's cast by the sun. And if that happens, if it's just at the right angle, it passes through there and it doesn't cover it up completely, but it turns it into like a really dark red, kind of bloody, sometimes orangey color. The reason why it doesn't block it out completely is because there is some refraction of light from the sun that happens through our atmosphere that causes the longer wavelengths, the reds and the orange, to actually make it to the sun, to the moon. I had an animation that illustrated this whole thing and I cannot find it, so I'm sorry about that. But I did do a video on phases of the moon, so if you're interested in that or you need some help understanding how that all works, go check that out. That will help. But basically on Friday, the moon will pass through the Earth's shadow, and then 2 weeks later the moon will pass in between the Earth and the sun, and it will cast a shadow on the Earth. So there will be a portion of the Earth where the shadow crosses that will see a solar eclipse. Now, unfortunately, the part of the Earth where that happens is mostly over the ocean. But as we get closer to that, I'll talk more about the eclipse. You see, I've got my eclipse thing from last year's eclipse. Eclipses are really fun, and they're interesting coincidences of geometry between the Earth, the moon, and the sun. And another point of trivia, did you know that, as far as we know, we're the only planet in the solar system that has these total eclipses? Because our moon is big enough and in just the right distance away that it looks like it's the same size as the sun. So it just happens to do that. If we had appeared on the scene a couple million years from now, that wouldn't be the case. So we have that to look forward to. All right. Sky watching. I almost forgot about the sky watching. What have we got here? Have you been watching Jupiter? I took my binoculars. I got some high-power binoculars. I took them out there and I could see 3 of the moons. It was really nice. But the weather here has been kind of sketchy. We've had a lot of storms. But Jupiter is really bright up in the sky most of the night. Mars is closest to the Earth than it has been and will be for a while. So it's big and bright. It's brighter even than Jupiter, which is very unusual. You'll see that in the west after sunset. and it'll have an orangish tint to it. On Thursday, we have the first quarter moon. Can you visualize what that looks like? The first quarter moon. Think about that for a minute. On Friday, Jupiter will be 4 degrees south of the moon. So you can think, when I talk about degrees in the sky, if you hold your finger out at arm's length, then that is about 2 degrees. Okay? I mean, it's rough. Now, this is about 5 degrees. All right? So it's going to be, if you do this, that will cover the distance between Jupiter and the moon on Friday, which that's cool. That's pretty close in the sky. And if you have the right kind of equipment to take a photograph, that would be a really nice photograph. The moon will be just past first quarter, so it will be relatively bright. So keep that in mind. And then, let's see, what was happening on Monday? Oh, I know what else I wanted to talk about. This week, of course, is Moon Week. Moon Day, I think, is on Friday. Yes, because this is the week in 1969 that Apollo 11 launched, took 3 astronauts to the moon. 2 of them landed on the moon, walked on the moon, took some pieces of the moon, got back, launched off of the moon, rendezvoused with the spacecraft in orbit of the moon, and then went back to Earth and landed. Wow. So that all happened this week, except, no, they didn't land until next week, next Tuesday, but, this is a very exciting anniversary in spaceflight. It disappoints me that this is kind of the last, 1969? That's a long time ago. I wasn't even born then, and I'm old. So I'm ready for us to have another manned space milestone to celebrate. But until then, we have Apollo and the heroes that contributed to that, both in space and on the ground. All right, space geeks, that's it for me this week. I will see you next week with a whole new episode. And until then, don't forget to look up. Bye.
We choose to go to the moon in this decade and do the other thing.
Discovery, go at throttle up.
Discovery, roger, go at throttle up.
Not because they are easy, but because they are hard.
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Houston, Tranquility Base here. The